Welcome to the MuAnalysis video on counterfeit detection in the electronics industry. These are memory chips. The one on the left is the real part. On the right, the part was never finished as the encapsulant is missing. There is a different substrate and a thinner solder mask which is translucent. The fake part also used leaded balls on what was marketed as a lead-free part. When counterfeiters are trying to sell a leaded part into a lead-free requirement, they clean the part. However, using X-ray fluorescence, we can detect the residual lead. Here is another memory chip example. Both of these parts had the same lot code, so they should have been identical. X-ray on the parts showed that they both used a slightly different substrate. Here the differences were very subtle. These transistors had the same date code, and externally they may have looked the same. X-ray revealed that they had a different die. As these transistors came from the same reel, the entire reel is suspect counterfeit. 5 parts were selected at random from the same reel. X-ray revealed the differences. The 3 parts on the left appeared to be the same. The 2 on the right are very different. This entire reel is also suspect counterfeit. This X-ray image showed voids in the die attach epoxy. This could have been an assembly lot reject or perhaps even a used part. This part was decapsulated to expose the die. The part was found to have processing defects and was most likely rejected, and yet still found a way into the supply chain. This is a more clever example of counterfeiting. Both parts passed numerous tests that we previously discussed. These identical parts were decapped and viewed through a microscope. The only difference is that the suspect part on the left had a different die marking than the reference part on the right. These parts had identical part numbers, but they were a different revision. The part on the right is real. The part on the left looks genuine, but had a mask missing. The differences are becoming very, very subtle. The part on the right is the real part. The part on the left is a clone. By now, you probably can detect how the part on the left is different in so many ways from the part on the right. This is a flip chip example. With flip chip, we only have visual access to the back of the die. Infrared microscopy allows us to see through the die. We can read logos or markings, as in the red highlight, which is the Sony logo. Many parts are now flip chip. Infrared microscopy allows us to also spot defects, which is one method to determine if counterfeits are making their way into the supply chain. MuAnalysis is offering a half-day course on failure analysis techniques to groups of 5 or more. If you would like to take advantage of this course, please contact us. MuAnalysis services enable manufacturers to reduce design time, reduce returns, and maximize product yields. Thanks for watching.